degrees Celsius in a city on a particular day is modeled by the function t, defined by t as a function of time, and this is the rational equation where t is measured in hours from 12 p.m. for 2 is less than or equal to t and t is less than or equal to 9. Based on the model, how many hours did it take for the temperature to increase from 0 degrees Celsius to 5 degrees Celsius? Well, first of all, this is a calculator problem, and as you can see, I showed you some screenshots here. So let's look at the first screenshot here. So what you do first is you press y equals, and then I pressed alpha y, and on the first choice I'm able to write the fraction. So I put in the fraction exactly as you see it in the original problem, and notice that on y2 I put 0 because we want it from 0 degrees Celsius. I want to know when these two intersect. Okay, and so in order to do that, we press second trace for calc, and on the screen you will see calculate, and you choose number 5 for intersect. And when you do that, you will see this screen. It will ask you first curve, and that's the equation of the first curve, and that's the blue one. Notice blue writing matches blue curve. And you'll see a little cursor. Make sure the cursor is, you use your arrows in order to get the cursor on this curve, only on the curve. Then you press enter. Next, it will ask you second curve, and remember the second curve, it actually shows up in a different color, and then you will highlight the second curve. It will be red, and then enter. Then you press enter a few times because it'll ask you guess, and then finally you'll get the actual intersection. Let me go ahead and write that number down. So it's 5.420253. So from the graphing calculator, the intersection when y is 0 is the following. It is x equals 5.420253. And now we have to do the same thing for when the intersection of this function is with 5. And so we do the same idea. We go back to y equals. You keep the first as y1, which is the original equation. And then on y2, you put 5 because you want the intersection at 5 degrees Celsius. And then you go through the same process. You press second trace for calculate, and then you press 5 for intersect, and then again, blue writing, blue curve, first curve, you move the cursor on the curve, press enter, then it'll say second curve, then red writing for the red curve, enter, then it'll say guess, enter. I kind of put it near the point of intersection, enter, and then finally it'll give you the intersection. And so I'm going to write that number down. So it was x equals 7.7007238. So this was the first one, so I'll call this x1. This is the second one, so I'll call this x2. We wanted to know what was the temperature increase, so we'll subtract x2 minus x1. So it's the 7.7007238 minus the 5.420253, and we get 2.2804708, which rounds to choice D.